Hey everyone, Mr. Newman here. Today we're going to learn about some exponents. First of all, what are exponents? What is an exponent and how does it work? Well, you guys know that x cubed means x times x times x. So in one sense, an exponent, that 3 up there, just tells you how many times to multiply x out. But that kind of understanding doesn't get at the whole picture, and there's going to be some problems with that here in just a second. For example, x squared means x times x, right? Hopefully you all also know that x to the first means x, but that doesn't mean we multiply x by itself one time. That just means we only have one x and there's no multiplication happening at all. So so we know, the exponent, when I say the exponent, I mean the thing in the power, and so here there's an invisible 1 in the exponent. So the base is the number in the bottom. That's the thing that you're multiplying over and over and over. The exponent is how many times you multiply that, and that's the little number up top. The power is the word for the entire thing. So I'm going to try to stick to this vocabulary very carefully, so then when I say add the exponents or multiply the power, you know exactly what I'm talking about. Now, let's get to the first dilemma. What the heck is x to the 0? Well, first thing I want you to do is look over here to the right. See 2 to the third? We're going to draw a little pattern here, and we're going to try to figure this out. So 2 to the third is 8 because it's 2 times 2 times 2. 2 squared is 2 times 2. That's 4. 2 to the first is just 2. And you notice what's happening each time as we go down. We're dividing by 2 as we take a step down with the exponent. So if we continue this pattern, divide by 2 again, 2 divided by 2 is 1. So 2 to the 0 power is 1, and we get our first rule. Anything to the 0 power is 1. That's a rule you can remember. Now I say almost anything. There's one exception. 0 to the 0 power is a special case, and it depends on what situation you're in as to what that is. But anything else to the 0 power is always 1. One of the things that people mess up with exponents is they default back into multiplication and they think, oh, it's multiplying. X times 0 is 0. No, do not make the mistake of thinking you're multiplying by that number up there. That is a special, different operation than multiplication. So, go ahead and make a guess. What is x squared times x cubed? If you have never seen this before, you might have said x to the 6th, but that is not correct. What it is we're getting to our next rule. If you multiply the powers, that means you add the exponents. Remember, the power is the entire thing. The exponents are the small numbers up top. Well, before I show you some examples, so let's talk about why do we do that. X squared times x cubed. Well, what does x squared mean? It means x times x. What does x cubed mean? It means x times x times x. So x squared times x cubed simply means x times x times x times x times x. In other words, x to the 5th power. Do you see what we did right there? X to the 5th exponent. The exponents had to be added because the exponents tell us how many times we multiply the base. And if we're multiplying everything out, then adding the exponents is just simply how many x's there are when you're multiplying everything out. So let's use this new rule of when you multiply the powers, you add the exponent. X to the 4th times x to the 7th. 4 plus 7 is 11, so you get x to the 11th. Here for the next one, when you have a coefficient, that's the 2 there, you can treat that just like normal multiplication. And so I'm going to write 5 plus the exponent 2 gives us an exponent of 7. So we have 2 times x to the 7th. Notice the exponents are only on the x. The coefficient is not affected by the exponents in this case. For this third example, there are 2 exponents and 2 coefficients. There's the invisible 1, remember that? So it's x to the 1st. So we're going to do 1 plus 6, And we still multiply the coefficients. Just because we have this new rule where we add the exponents, that doesn't mean we all of a sudden start adding things that we multiplied beforehand. So we only add the exponents. So 5 times 3 is 15, and we get x to the 7th because 1 plus 6 is 7. All right, moving on. Now we have division. So I just want to point out that first thing we did, x to the 6th, that's the most common mistake when you're multiplying exponents, is students accidentally multiply, or when you're multiplying powers, students accidentally multiply the exponents. All right, let's make a guess. What if we divide powers? X to the 6th divided by x squared. Well, if you said x to the 3rd, you are incorrect. And we get to our next rule. When you divide powers, you subtract the exponents. Why is that? Well, let's write it out. X to the 6th divided by x squared looks something like this. Now you all know that x divided by x equals 1 because anything divided by itself equals 1. So what I'm going to do is I'm going to write a 1 on top of that first x divided by x and that second x divided by x. In other words, that's 1 times x times x times x times x. Or it's just x to the 4th, since multiplying by 1 doesn't change the expression at all. Notice that those divide out, the x's divide out and leave us with x to the 4th power, x to the 4th. So let's use the new rule now to divide these powers. X to the 5th divided by x cubed. 5 minus 3 is 2, since we're subtracting the exponents, so we get x squared. Remember the invisible 1, so 7 minus 1 equals 6 because the exponents are 7 and 1, and we get x to the 6th. Here, 3 minus 6 is negative 3. Uh-oh. Well, don't panic. We're going to talk about negative exponents in just a second, but for now, just recognize that that is x to the negative 3rd. If you wrote out the exponents and you got 1 over x cubed, you are also correct, and you're going to see why in just a second. So the most common error here is to divide the exponents, but you don't do that. Anytime you divide powers, you're supposed to subtract the exponents. Let's move on to the last rule. If you make a guess, x to the 5th, and all of that raised to the 2nd power, what do you think we should do? If you guessed 5 squared is 25, that is incorrect. So, when you raise a power to an exponent, you are supposed to multiply the exponents. Why is that? Well, what is anything squared? Anything squared means take that number and multiply by itself. So x to the 5th squared means x to the 5th times x to the 5th. And we know our rule from above, when you multiply powers, you're supposed to add the exponents. So 5 plus 5 gives us 10. Well, that always works. When you have two numbers, a power raised to another power, you always multiply those exponents. So let's use this rule. X to the 3rd raised to the 4th, that's 3 times 4 is 12, so we get x to the 12th. X squared to the 5th, 2 times 5 is 10, so we get x to the 10th. Now I picked this one because I wanted to show you guys something special. Just like you can multiply 2 times 5 and 5 times 2 and you get the same result, you can also raise a power to an exponent and you get the same result there. X squared to the 5th power is the same as x to the 5th squared. They're both x to the 10th. The last one here, 10 times negative 2 is negative 20, so we get x to the negative 20th. And now we've held off on exponents for too long, negative exponents. Let's talk about negative exponents. We need to rewrite our last pattern that we had, only I'm going to keep going with this pattern. So we had 8, 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the first is 2, and we know that anything to the 0 power is 1. Notice the pattern of what's happening. We're dividing by 2 each time. So what if we keep doing that? Well, 2 to the negative first, that's the next step, is 1/2. And just divide in half again. Half of 1/2 is 1/4. 2 to the negative second is 1/4. That is the same as writing 1 over 2 squared. 2 to the negative third, we're dividing by 2 again, that's 1/8. And this is the same as 1 over 2 cubed. Let's divide 1/8 in half one more time, we get 1/16, and that's the same as 1 over 2 to the 4th. I hope you are starting to see the pattern here. And this gets to our very, very last rule. A negative exponent is the same as the reciprocal of the positive exponent. Now, whoa, what do I mean by the word reciprocal? If you haven't heard this word before, it's a common term in math with fractions. The reciprocal is when you flip a fraction. In other words, 2/3, the reciprocal of 2/3 is 3/2. These are not equal. I'm not saying that 2/3 and 3/2 are equal. They're just reciprocals. And the reciprocal of 5, for example, is 1/5. The reason for that is because you can write 5 as 5 over 1, and the reciprocal of 5 over 1, you flip that fraction, is 1/5. So reciprocals are not equal if you simply flip a fraction. However, what I'm saying down here is the negative exponent is equal to the reciprocal of the positive exponent. In other words, if you flip it and change the negative exponent to a positive exponent, you get the same thing. Look down here where we have 2 to the negative second became 1 over 2 to the positive second. And 2 to the negative third is equal to 1 over 2 to the positive third. 2 to the negative fourth equals 1 over 2 to the positive fourth. So let's use this new rule and let's rewrite the negative exponents as a positive exponent. Well, x to the negative third, we need to flip it. Well, what do we flip? If it's over 1, we flip it and say 1 over x to the positive third. And that is the positive way you write it with a positive exponent. X to the negative fifth, that's going to be 1 over x to the positive fifth, or just 1 over x to the fifth. Lastly, 1 over x to the negative fourth, well, we have to make it positive by flipping it. And so we flip it and make it positive. Well, did I flip it? Yes, because that's really x to the fourth over 1, but you don't need to write the divided by 1 because anything divided by 1 is itself. Thank you very much for watching, and take careful note of these rules as we use these to practice in class.